So what we're going to do is we're going to look at some common functional groups that we'll run across with the organic molecules we're going to be analyzing this year. Now remember, a functional group is just an arrangement of atoms that give the molecule its chemical and physical properties. So for example, in this molecule here, having the OH group would mean that this molecule would have dipole-dipole attractions and hydrogen bonding, which would drive a lot of its physical properties, but also having the OH group would tell us what kind of reactions it could be involved in. When we're naming organic molecules with more than one functional group, the one with the highest priority gets named in a suffix, and the lower one gets named in the prefix. Okay, and so we just have to know or have an idea of our priority, their list of priority. So what I'm going to do is I'm going to start off at the lowest priority functional group and work my way up to the highest priority functional group. Okay, so here we can see our priority list, and alkanes, so this means our branches would be the lowest priority, and then we go up from there. The second lowest priority would be a nitro group. It's an NO2- group, and it would be attached to one of my carbons. Okay, and it's only named in prefix with the prefix nitro. Then we have our acyl halides. These are where we had halogens to our hydrocarbon chain, and we'll be looking at a number of molecules. This is a very useful thing to add on to the carbon chain because it allows us to then do some other reactions. And they're also only named in prefix, and the prefix depends on what halogen it is. Whereas ethers are our next one, and we recognize ethers by having two carbon chains attached to one oxygen. And the longest carbon chain is my root. The shorter carbon chain would then be named in prefix, but because it's attached to an oxygen before the main chain, we name it with an oxy instead of the YL. Then we have our amines. These are where I have nitrogen attached to my carbon chain, and they're often called derivatives of ammonia, where I take an ammonia molecule and I start replacing the hydrogens with carbons. And I can have three different types depending on how many hydrogens I replace. So here's my ammonia. If I replace one hydrogen with a carbon chain, denoted by my letter R here, that would be called a primary amine. If I replace two hydrogens with a carbon chain, then that would be a secondary amine. And if I replace all three hydrogens on my amine with a carbon chain, that would be a tertiary amine. And this will change the properties of the amine, as well as the reactions it can be involved in. So when we name it, and it's a highest priority, it's named in a suffix with the amine, and when it's not the highest, it's named in a prefix as an amino. Also, if we have a secondary or tertiary amine, then the location of the second or third acyl group is stated as N, since it's bonded to the nitrogen before the main chain. So for example, here I can see that this is my longest chain, and it's 3 carbons long, so it's a prop, and there's only single bonds, so it's a propane, and then it has an amine on it, so it'd be a propanamine, and I have to state where it is, and so it'll be on carbon number 1. Then here I have a second acyl group on my nitrogen, and it's 1 carbon long, so it's a methyl. So now when I go to put these two parts together, since the methyl is attached to the nitrogen before the main chain, this will be an N-methyl. Our next group that we're going to look at are alcohols. They have a hydroxyl or an OH group, and similar to the amines, they can be classified by type, where we can have a primary alcohol where the carbon that it's bonded to the main, that the hydroxy group is bonded to, is only bonded to one other carbon. We can have a secondary where the carbon that the hydroxy group is bonded to 2 other carbons. And we can have a tertiary where the carbon that the hydroxyl group is bonded to 3 other carbons. Okay, if it's the highest priority, it gets named in a suffix OL. And if it's not the highest priority, it gets named a prefix as a hydroxy. Okay, our next group is a carbonyl group, and a carbonyl group is just a carbon double bonded to an oxygen, and it can be located either at the end of the chain or in the middle of the chain. And if it's in the middle of the chain, it's a ketone, and if it's at the end of the chain, it's an aldehyde. An aldehyde gets a higher priority than a ketone because it's at the end of the chain. So here we have our prefixes and suffixes, and so here, for example, we can see in this molecule, I have both a ketone and I have two aldehydes. So if I went to name this, my root would be pent, intersingle bonds, ane, and I have two aldehydes, so it'd be a diol. And since they're on both ends of the chain, it'd be 1,5. And then I have a ketone in the middle, and since it's not the highest priority, it would get the prefix oxo, and it'd be 3. Okay, carboxylic acids are actually my highest priority. And so they're only named in suffix, and they consist of two functional groups together. We have our carbonyl group and a hydroxyl group. But they're our highest priority. Okay, and so as a result, they're only ever named in suffix with oic acid. So therefore, for example, this one here, 4 carbons long, so it'd be a butanoic acid. The reason we did carboxylic acids first is because they help, or knowing them helps to be able to name or identify our other two groups. So our esters are actually our second highest. And when we look at it, it consists of a carbonyl bonded to another oxygen that has a carbon chain. So we almost have a carbonyl and an ether on the same one. And when we want to name this, the naming is dependent on our source. Okay, so we always name it based on the parts that make it up. The part that was a carboxylic acid is always our root, regardless of the name, the size. So what I can do is I can draw a line through the oxygen, and the side with the carbonyl, this was from my acid. And the side without the carbonyl, this was from the alcohol. And so as a result, this is my root, and this would be in prefix. And so now I would name this. This is a 2 carbon long, so it's an ethane O8. And then this is my prefix. It's a propyl. We don't need to state the name, or sorry, the location of the propyl. It's a given, but you'll notice I left a space here. This is the only time we leave spaces in our organic names. So we would have a space here in this name. Our amides are similar to our esters in that they consist of 2 functional groups attached to the same carbon. So here I have my carbonyl again, but now I also have an amine. And so they form by the reaction between a carboxylic acid and an amine. So similar to carboxylic acids, my part that was a carboxylic acid will always be my root, and the other carbon chains would be named as side chains with their location stated as N, since they're bonded to the nitrogen. I will not give you a amide with a carboxylic acid, so we don't need to worry about the prefix for it. If I was to name this one, I'll draw a line between the carbon and the nitrogen. And so this tells me, lets me see that I had a 2 carbon root, so it would be an ethanamide. And because it's the highest priority and it can only be at the end of a carbon chain, I don't have to state its location. And then I have a methyl group and a propyl group, so this would be N-methyl. And this would be N-propyl. And so now I just put together alphabetical order. And so therefore it'd be N-methyl, N-propyl, ethanamide.